Welcome to the project demonstration of IOT battery management system along with ThinkSpeak cloud storage. So in this project we are continuously measure the battery packs voltage. So we are using the battery pack 1, 2, 3. So the voltage measured by this voltage sensors and continuously displaying on the LCD screen. And the next feature is whenever the respected battery voltage is less than the threshold value. So we set the threshold value of 8 volts. So whenever the battery voltage is less than 8 volts, that's 0 to 8 volts, then the system will on this electromagnetic relays respected to charge the respected battery. So for example, so if the battery voltage 1 is low, then this relay gets switched on, so which will allow the charger voltage to the battery pack, so that this system continuously monitoring and maintain the battery levels in a healthy manner. And also it will provide us the temperature monitoring. So whenever the temperature crosses 45 degrees centigrade, then the system will provide us audible alert to the buzzer. So that temperature increasing may due to the overload or overcharge or overcurrent, or is there any short circuit occur inside the battery packs. So that is a thermal protection for the battery packs. So it will achieved by this temperature sensor and our microcontroller. So these features are executed and running inside this PIC16F73 microcontroller, continuously taking input from the voltage sensors, and they are displaying the same data on the LCD screen, and based on the voltage values will control the electromagnetic relays to charging purpose. And whenever the voltage temperature is above 45 degrees centigrade, then it will switch on this buzzer. And another component is like Wi-Fi module. So with the help of this ESP8266 Wi-Fi module, the system continuously uploading the respected battery voltages along with SOC, SOH also. So SOC nothing but state of charging, and SOH nothing but state of health. So SOC will be getting from the battery charging ratio. So if the battery is charging according to the current rating of the charger, so we are providing 1 amp input from this transformer, and as we are using the 1 amp of current for this battery packs. So coming to the battery packs, in this we can see the 3 battery packs connected in series. So we'll get 12 volt 1 amp DC output. Same for the remaining 2 battery packs also. So for that we need to provide the 1 amp of current for charging purpose through this charging circuit. So whenever the charging increases according to the ratings of the charger and the battery voltage, then the SOC will be near to the 95 to 100%. If the battery was not charging according to the input current values, then it will affect the SOC value, so that we can get to know about the battery health condition by seeing the SOC about the charging status. Same for the SOH also, the state of health, how the battery voltage is decreases. So if it is rapidly decreased, that will affect the SOH values just like SOC values. So these two are the main for charging sustainability inside the battery pack. And next let us check the outputs. So let me explain the components clearly again. So these 3 are the 12 volt 1 amp batteries, and these 3 are the voltage sensors to measure the respective battery voltages. And this each voltage sensor consists of 2 resistors are connected in parallel as a voltage dividing ratio. There's a potential dividers. So there is a ratio of 10:1. Whenever the input voltage is 10, the output voltage is a 1. That is, we are dividing that voltage with using the 2 resistors. And that voltage will be multiplied again 10 by the microcontroller. Inside the program we write the logic. These 3 are the voltage sensors, 3 electromagnetic relays for allow the charging voltage to that. And the next, this is a charging power supply, regular power supply, and transformer 230 volts to 12 volts of AC 1 amp, 16:2 LCD screen, PIC16F73 microcontroller, motherboard, buzzer board, and ESP8266 Wi-Fi module. Right, so let us check the demonstration. So before switch on the power supply to the kit, the very first step is we need to provide the hotspot to the kit. So for that purpose, go to hotspot settings of your phone, configure the hotspot name to project 7389 without any space, without any capital letter. Password should be 129. That's 123456789. AP band should be 2.4 gigahertz. After enabling this hotspot along with the data, and now log into this ThinkSpeak cloud platform as you have given the credentials already. So this is a channel, just click on the IOT BMS. So there we get the previous tested data. So there's a battery 1 voltage. So while scrolling, don't touch on this blue bar, and battery 2 voltage, and battery pack 3 voltages. And whenever you click on this dots, we can get the so-called respected value of the sensor value along with the date and time, and SOC values and SOH values. So these are the continuously plotted into this cloud platform and this data can be accessed from anywhere in the world. Okay, now let us check with the demonstration. So after enable the data hotspot on the kit, and welcome message displayed on the LCD screen, as we can see on the temperature values and battery 1, battery 2, battery 3. This is a pack 1, pack 2, pack 3 voltages. The SOC, SOH values will be calculated after 10 to 15 seconds of duration based on the voltage variance in that battery packs, respective battery packs. So the overall SOC values will be displayed on the LCD screen. As of now, that's 36.5 degrees centigrade. So let us heat up this temperature sensor. Yeah, right, we got the SOC, SOH values on LCD. We can see that. Now just whenever the voltage temperature is above 45 degrees centigrade, then the high temperature and message on the LCD, and we'll get the audible alert through the buzzer. And when it is coming to normal, right, when it is below 45 degrees, it is a normal condition. And you can see that the data is uploading now. Okay, so the time is 10:12, so it's uploading the data. Now if you are getting clumsy data, just now you can erase this old data and you can get the fresh data also. So before erasing the data, go to data import export, download the data for backup purpose. Download the data, so it will be download an Excel sheet, and we can access the data along with the date and time, along with the number of entries till now we have collected, along with field 1, field 2, field 3, like that. So see the date and time and number of entries CH, and field 1, field 2, field 3 are the voltages, temperature, SOC, SOH values. Total 6 fields we took the backup. So after we took the backup, now go to channel settings, and in that only do clear the channel. Don't delete the channel, only clear the channel. So once channel got successfully cleared channel, now you can see the old data got erased. Now wait for 10 to 15 seconds duration, because the ThinkSpeak accepts the data for every 15 seconds of duration only. Keep on updating the data on the ThinkSpeak. Now let us check with the voltage fault, because if you want to make the voltage fault, generally we need to wait till the battery got discharged. In meanwhile, just I'm disconnecting the respective battery pack from the voltage sensor, so that there is no input to the voltage sensor, so it is getting the low voltage inputs, and the so-called battery pack 1 relay got switched on. So as we can see, the P1, the battery pack 1 voltage is 0.0 volts, and also low battery voltage message alert on the LCD screen. Just connect it back, means so the system doesn't know about that you disconnected or connected. Just it's checking the voltage levels over there. If it is below 8 volts on the relay, about 12 volts of the relay, you can see the data is coming on this one. Again battery pack 2, so battery pack 2 is low, and again battery pack 2 is on. Again battery pack 3, right, okay, so battery pack 3 got switched on. So in this manner we are continuously measuring the voltages along with the SOC, SOH calculation and thermal protection. Thank you.